All right, so welcome to this video. So in this video, we are going to look at questions, okay, in physics. And the topics that we're going to discuss are unit conversions, dimensional analysis, and how to derive units using dimensional analysis, okay? All right, so let's start. Okay, so the first question here, they're simply saying, um, name the SI prefixes below and state their value. Okay, so these are the prefixes here. Okay, so the prefixes come from what we call as the metric system. So the metric system here it is there down. Okay, it's just a system, okay, of 10 and its multiples and its sub multiples. Okay, so this metric system, okay, um, has a prefix, okay, its symbol, and then its value. Okay, so the only thing that you have to do in order for you to solve this question here is just to memorize the metric system. Okay, not two ways about it. So you can see here that different prefixes have different symbols, okay, and they have what? Different values. I can also see here they have different names, okay, different symbols, and then different what? Values. Okay, so those are the prefixes there. So, for example, if you go at kilo, okay, so this is kilo here. So the prefix is kilo. Its symbol will just be a K, okay, and its value will be 10 to the power 3, okay, will be 10 to the power 3. So these guys here are case sensitive, okay. So what do I mean by that? It means that you must be very careful because a capital letter and a smaller letter will not mean the same thing. Okay, so for example, when you look at the M, okay, I have this M here, which represents mega. You can see it. And then I also have this M here that represents MIDI. So the difference, okay, is in either it's a capital letter or it's a small letter. So for the MIDI, you've seen that it's a small letter there. Okay, and then this capital letter here, the M, is for the mega. Okay, so meaning that you have to be very careful as you are looking at the prefixes that you've been given. Okay, if it's a smaller letter, it will mean something. If it's a bigger letter, okay, or a capital letter, it will mean something. Okay, so now what is P? So P here, you've seen the way they've written it. That's a capital letter. Okay, so P capital letter, okay, the prefix that it represents is what we call as the penta. Okay, the capital letter P represents penta, and the value that it has, okay, is simply 10 to the power 15. So you can check it out from the table. That is the one there. Okay, so capital letter P represents penta. Its value is 10 to the power what? 15. So if you made a mistake here and thought this was a smaller letter P, then you would get it wrong because the smaller letter P, you can see here, it means pico, and its value is 10 to the power minus what? 12. Okay, so be cautious of the case, either it's a capital letter or a smaller letter. Okay, so it's case sensitive there. All right, the number 2, okay, this was 1. So number 2 is, this is a smaller letter F. Okay, so the smaller letter F simply means femto. Okay, same femto. Okay, so femto adds the value of 10 to the power minus 15. Okay, so that's the femto there. All right, and then what else? We have mu. So this guy here is called mu. So it looks like a U, but it has something like this one, like a cartel here. Okay, so that one is what we call as mu. So mu represents micro. Okay, so number 3, whenever you see mu like this, like a U with a cartel, okay, that represents micro. So micro has the value of 10 to the power minus 6. You can even see it from the table there. Okay, so make sure you memorize this because they'll just pick any of these and bring them. Okay, the next one is capital letter G. So capital letter G, what does it mean? Okay, so capital letter G simply means giga. Okay, so giga represents 10 to the power positive 6. Okay, that's I mean not positive 6, positive 9. Okay, so giga is positive 9. So those phones that you are buying, or those memory cards, they when they say what's the storage of a memory card, and then you say uh maybe the memory card is 32 GB. Okay, so this guy here, the G, represents the gigabyte, or I mean, it represents the giga. Okay, and then this B here, in terms of storage, is the byte. So when you say 32 GB, you're simply saying 32 gigabytes. Okay, so this G here, you can actually represent it by 10 to the power what? 9. So 32 gigabytes is the same as 32 multiplied by 10 to the power 9 bytes. All right. Anyway, we're not converting units, but I thought I should mention. So the G, capital letter G, represents giga, and it has a value of 10 to the power 9. The other one that we've been given there is capital letter M. So capital letter M, I talked about it. It's this one here. It's simply mega. Okay. So mega has the value of 10 to the power positive 6. Okay, so all of these here, we've assigned the name, okay, for the prefix, and we've also assigned its value, okay. But at your own time, okay, make sure that you memorize this whole table that you can see here, okay. Memorize it. I remember when we were in first year, as we even used to sing a song just to memorize this, okay. But we were starting at Pico here, okay, and then we're ending at Tera here. Okay, so it was like pica, nano, micro, milli, centi, deci, kilo, mega, giga, tera. Then we're done. So yeah, so they have a specific pattern. Okay, if you are saying them in order. So if you start pica, nano, micro, milli, you can see that the pica has minus 12. So this minus 12 will increase by 3. So it will go to minus 9, and then increase by 3 again, minus 6, increase by 3 again, minus 3. And then once it reaches minus 3, it starts to increase by 1. So I'm saying increase here because these powers are negative. Okay? So meaning that negative 9 is greater than negative 12 because they are negative. The one I'm saying increase. So when you reach at 3 or minus 3, it start now reducing by 1. So you can see centi is minus 2, deci is minus 1. Okay. Then when you come here again, you can see deca is 1, hecto is 2, and then kilo is 3. Okay. And then from the kilo, you start increasing by 3 again. So mega, 6, giga, 9, tera, 12, just like that. So make sure you memorize this because you never know what they can bring in the exam tests or quiz. Okay. We move to the next question. So this one is on unit conversions, and we're going to be using dimension analysis. So meaning that we have to know the conversion factors. Okay. So here they're saying a car travels at 100 kilometers, and then they have put hour, okay, to the power minus 1. So kilometers and then hour to the power minus 1. This is the same as kilometers, okay, divided by hour, or you can simply say kilometers per hour. Because we know that if a number is raised to a negative, okay, for example, I have a raised to the power minus x. This is the same as 1 over a to the power positive x. Okay, so this is what I did to this guy here, and then I multiply with a kilometer. So it is a kilometer, and then this one has power minus 1, so it is 1 over h to the power positive 1. So I multiply, I get kilometers, okay, over h, and then this one here is the same as kilometers per what? Per hour. Okay, so they're saying a car travels at 100 kilometers per hour on a motorway. Find the speed in meters per second. Okay, so simply meaning that we are converting from kilometers per hour, okay, to meters per second. So from the kilometers here, okay, we want to change to meters, and from the hour, we want to change to seconds. So we need to have conversion factors there. So we know that 1 kilometer is the same as 100 meters. Okay, and then we also know that 1 hour is the same as 3,600 what? Seconds. So we're going to use these conversion factors to convert. So I'm going to get whatever I have there. I'm going to say 100 kilometers. Okay, I'll write it in this way, divided by second. I mean divided by hour. Okay, and then now I'll be arranging these conversion factors such that the thing that I don't want should cancel out. So multiplied by, I'll draw a line, and then multiplied by, I'll draw a line again. So here I want to cancel out the kilometers. So the kilometers, you see, they're on top. So here I'm going to put them down. So I'll arrange this conversion factor in such a way. So 1 kilometers, okay, and then 100 meters, so that the kilometer and the kilometer cancels out. And then the other one, I want to cancel out the hour. So the hour will be on top here, and then it's the same as 3,600 seconds. Okay, so now we see that the kilometer and the kilometer cancels out because they are on the opposite side. Even the hour and the hour cancels out. So on top, I just remain with 100 multiplied by 1,000 meters multiplied by 1 divided by 1 multiplied by 1 multiplied by 3600 seconds. Okay, so when I multiply whatever was on top there, what do I get? Okay, so I have 100 multiplied by 1,000 meters. So I get 100,000 meters divided by 3600 seconds. Okay, so you can see our desired units are there, meters per second. Okay, so now we just have to divide that onto the calculator. So let me write it here. So this will be 100,000 divided by 3600. Okay, so I'm going to get 27.7, okay, 8, and then meters divided by seconds, which is the same as 27.78 meters per second. Okay, so that 100 kilometers per hour is the same as 27.78 meters per second. So we have converted it. Okay, let's go to the other one. So the other one is this guy here. So they're saying convert 3 grams per cubic centimeters to kilograms per what? Cubic meter. Okay, so there I already explained on number one. If they write something like this, then they just mean, okay, grams divided by cm to the power 3, which is the same as grams per cm cubed, right? No wonder I'm writing like that. So want to convert from grams per cubic centimeter to kilograms per meter cubic. Okay, so we have to find the conversion factors. So the first conversion factor is very simple because I know 1 kilogram, okay, it's the same as 1,000 grams. Then the other one, this is centimeter cubic, and this is meter cubic. So to find the conversion factor, I'll first use the one that I know. So the one that I know is 1 meter is equals to what? 100 centimeters, right? This is what I know. So from here, I'm going to cube both sides. So 1 meter, I cube it, and then on the other side, 100 centimeters, I cube it again. So meaning that this one here just be 1 to the power 3, which will just still remain 1. And then m to the power 3, it will be m to the power 3 is equals to. Then here, 100 to the power 3, okay? 100 to the power 3 is going to give you what? Okay, so 100 to the power 3 is going to give me 1 million. Okay, so I'll just say 1 million here. So 6 zeros. And then this cm to the power 3 give me cm to the power 3. So this will be the conversion factor, okay? From converting from these cubic centimeters to cubic meters. So now I arrange them in a dimensional analysis form. So this is 3 grams divided by cubic centimeters, and then I'll say multiplied by, okay, I want to cancel out the grams, so I'll say 1,000 grams down. Okay, it's the same as 1 kilometer, kilogram. Then multiplied by, I want to cancel out these cubic centimeters. So the 1 million, I put it on top here. Okay, cubic centimeters, it's the same as 1 meter cubic. Then from there, I just cancel out the units that I can cancel. So the gram and the gram, they go. And then the cubic centimeter, they go. Okay, so on top, I have 3 multiplied by a million. Okay, and this kg. And then down here, I only have the 1,000 and the cubic meter. So that would be like 3 multiplied by 1 multiplied by a million. I get 3 million. Okay, and the kg there divided by, here I have 1,000 and meter cubic. So that is 1,000 meter cubic is equals to. So now you see here I can cancel out some of these zeros. So cancel these 3 zeros, cancel these zeros. So 1 into 3,000, I just get 3,000, okay, kgs per cubic meter. Okay, so that's how we can convert, okay, that one to kilograms per cubic meter. Okay, so done question 2. That was on unit conversions. Let's look at question 4. Okay, where we are deriving base units using dimensional analysis now. Okay, so when you're deriving base units, okay, it's very important to know different formulas of things that we've been using. Okay, so from secondary school as we are in grade 10, there are some formulas that we'll be using. Okay, so we'll be using them as we derive the base units for whatever you've been given. Okay, so here the question, they're simply saying derive the base units of each of the following. Okay, so the base units, we know that there are 7 base units, right? Okay, so meaning that we're just simply expressing the units of whatever we've been given there, okay, in those 7 base units. Okay, so there's the mass there, there's the kg there, there's the meter, there's the ampere, okay, there's the kelvins, there's what else is there? There's the mole, there's the candela, and then there's the meter for the length. Okay, so those are the 7 base units. So we're going to be expressing each of these in those base units. So let's start with the pressure. So here you have to know the formula for pressure. Okay, so we know that pressure is equals to what? Force over area. That's what we learned in grade 12, right? Okay, and then this force, okay, this force here has another formula again. We know that force is equals to mass multiplied by what? Acceleration. So I'm going to write where this force, I write mass multiplied by acceleration divided by area. Okay, so now I will just replace these variables here with their units. Okay, so what is the SI units for mass? Okay, so the SI units for mass, they are the kgs. Okay, multiplied by, and then this is acceleration there. So the SI units for acceleration are simply meters, okay, per second squared like this. So now, as we'll be solving questions on dimensional analysis, okay, we won't be writing this per second, something like that. We'll be writing it as a negative power because this one, okay, the way it is, let me write it here. It's the same as, okay, meters divided by second squared, which is the same as meters multiplied by 1 over second squared, which is the same as meters, and then I bring this on top. So it's going to have a negative power. So it will be s to the power minus 2 like that. So this one, I'll just write it like that. Okay, but where is it coming from? So remember, acceleration is equals to the change in velocity or the change in speed, okay, divided by time, right? So now, what is velocity? Okay, I want to go back to where it starts from. So velocity, okay, velocity is equals to the distance that you have traveled divided by the time. So the distance, this is just simply length. So the base unit for the length is just meters. And then the time, okay, is what? Second. So the velocity, okay, has the units meters per second, right? Okay, or in short, we can write meters s to the power minus 1. These are the units for velocity. So here, this change in velocity will still have these units because it's just a change in velocity, still velocity. So meaning acceleration is going to have the units for the change of velocity are just going to be meters, s to the power minus 1, and then the time is s. So now I take s on top there. Okay, so it will be m s to the power minus 1 multiplied by this guy here is the same as 1 over s. Okay, meaning that it will be the same as s to the power minus 1, which will just be m. And then these ones are the same base, so we can add their powers. So it will be s. What is minus 1 plus minus 1? That will be minus 2. Okay, so that's where the units for the acceleration are coming from. So I've shown you where they're coming from, okay? But in the exam or in the tests, you can just simply state that acceleration as these units. Okay, but I've shown you where they're coming from. Okay, so we have replaced the units, okay, for the for the mass, okay, and for the acceleration, which we said we are going to be writing as m s to the power minus 2 divided by. Then what are the units for area? So now remember, area is measured in meters per second because, for example, I want to find the area of a rectangle, okay, or a square in short. So this is the length, this is the length. So I'll just say area is equals to L squared, right? So L is in meters. Okay, I multiply by another L, which is in meters. So I get M squared. So the units for area will always be what? M squared. Okay, and then this one, I'll just write it as kg multiplied by m s to the power minus 2, and then multiplied by 1 over m squared. It's still the same, right? I've just separated this guy so that this guy now can go up, okay, and have a negative power. So it will be kg multiplied by m s to the power minus 2 multiplied by m to the power minus what? 2. Okay, so that is what we have there. So this will be kg, okay? So this is m and this is m, and they have the same base. So this m here is to the power 1, this one is to the power minus 2. So we add the powers, okay? 1 plus minus 2, that will just give me m to the power minus 1, and then s to the power minus 2. Okay, so these units here are the base units for what? For pressure. Okay, so those are the base units for the pressure that we were finding. So a common name that is given to them, okay, they are known as the Newton. Okay, so the Newton is oh no, not the Newton here. That's the Pascal. Okay, the common name they are called Pascal. Okay, or they're simply thought to be Newton per meter squared like this. So Newton per meter squared like this, or the Pascal, is the same as this guy here. Okay, so those are the base units for the pressure. Let's derive the ones for the force. Okay, so we'll be using the same principles. So force, I've already derived it, right? As we're deriving for the pressure. So force is equals to ma. So the units for mass, kgs, multiplied by the acceleration, we saw how we derived it. That's simply meters s to the power minus 2. So these units here are the units for what? For force. Okay, let's do impulse. So impulse, you have to know the formula for finding the impulse. Okay, so the impulse, when you're finding it, its formula is force multiplied by t, which is time. So force, okay, we're just from deriving its units, which we just said kg, meter, and then seconds to the power minus 2. Okay, so I'll multiply this by the units for the time. So units for the time, the base units is just what? Second. So this will be kg, m, and then this is s, this is s. Okay, this is s to the power 1. So they have the same base, so I can add the powers. So that will just simply be s to the power minus 1. Okay, so those are the units, or the derived base units for the impulse. All right, let's look at potential energy, okay, or gravitational potential as they are putting it here. So energy has a lot of formulas, okay? Energy has a lot of formulas, but the derived base units are always going to be the same, no matter what formula of energy that you are going to use. So here they have said gravitational potential energy. So I'll use that formula. Okay, so gravitational potential energy is equals to m multiplied by g multiplied by h. So this m here is the mass, okay? And then the g is the acceleration due to gravity, okay? And then the h is just simply the height. Okay, so we know that for the mass, the units are the kg multiplied by, this one here is gravitational. It's the acceleration due to gravity. So as long as it's acceleration, it has the same units as the normal acceleration. It doesn't matter if it's acceleration due to gravity. As long as it's acceleration, it will have the same units. Okay. So acceleration, we said its units were what? Were m s to the power minus 2. Then multiplied by the units for the height. So height is the same as length. So length is measured in meters. Okay, so this one is just going to be kg. Okay, and then this is m and m. So this is the power 1, this is the power 1. So I can add their powers. So that would be m to the power 2, then s to the power minus 2. Okay, so these are the derived base units for the what? For the gravitational potential energy. But it doesn't really matter, even any energy that you can think of, okay? Kinetic energy, okay, whatever energy that you can think of, it will still have these units here, okay? So let's prove it maybe. So for example, if I get kinetic energy, okay? Kinetic energy has the formula 1 over 2, okay, m, and then v squared. So when you're deriving units, you always ignore constants. So this guy here is a constant, so I ignore it because it's dimensionless. It doesn't have any units, or it doesn't have any dimensions. So the units for the m, which is mass, is kg, multiplied by, okay, the units for the v. Now v is velocity. Okay, so now remember velocity or speed is simply distance over time, right? So distance is meters, and then time is second, which is the same as meters second to the power minus 1. Okay, so meaning that I'm going to put wherever there's v here, I'm going to put m s to the power minus 1. And then since v is squared, I'm going to square this. So you see that we still end up with kg, okay, meter squared s to the power minus 2. Okay, because this 2 goes to the m squared. This 2 goes to the s minus 2. Okay, so you see that they're the same. So whatever energy that we can think of, okay, the units are always going to be the same. Okay, the units are always going to be the same. Okay, let's look at Young's modulus. Okay, so here you can do some research. Okay, so Young's modulus indicated by a capital letter Y is equals to stress, okay, over strain. So now this stress here is the same as pressure. Okay, so stress is the same as pressure. So I'm just going to say stress here. Okay, it's the same as pressure. And then on number 1, we said pressure was force over what? Area, right? That's what we said on number 1. And then this strain here, strain has no units. It's dimensionless, okay? So meaning it's not going to contribute any units there. So meaning that the base units for the Young's modulus will only depend on the stress because it's the one that has dimensions. This strain here does not have dimensions, okay? So now we remember that this force is the same as mass multiplied by acceleration, then multiplied, divided by the area. So, okay, so the mass, the units for the mass is kg, and then the units for the acceleration, that is meters, s to the power minus 2, divided by the units for the area, this is just m squared. Okay, so I take the m squared on top to be kg, okay, multiplied by m, s to the power minus 2, multiplied by m to the power 2. So this will just be equals to kg. This is m, and this is m. Oh, here, that it has to be minus 2 because that's come on top. So 1 plus minus 2, that would be m minus 1, s to the power minus 2. Okay, so these are the units for stress. And then we said the strain is dimensionless. So I'm just going to write for the stress is kg, meters to the power minus 1, s to the power minus 2. And then this one is stress, the strain is unitless or dimensionless. So I just put a 1 there. So I divide, I still get kg, m to the power minus 1, s to the power minus 2. Okay, so those are the derived units for Young's modulus. All right, let's look at ohms. Okay, we are deriving the base units for the ohms. So we're going to derive that using the formula, okay, that relates the it relates the uh it relates the resistance, okay, voltage and the current. So remember, when you are in grade 12, you are saying voltage is equals to current indicated by I multiplied by the resistance, right? So we know that ohms are actually units for the resistance, okay, for the resistance. They're actually units for the resistance. So I'll make resistance the subject here. So I'm simply meaning resistance is equals to voltage over current. So now current, okay, is one of those base units of the 7 base units, and its units are just amperes. Okay, its units are just amperes. And then now we have to find the units for the what? For the voltage. Okay, because we know that the units for this resistance are the ones which we call ohms. So whatever units are going to come out of this combination here is what we call as the ohms. Okay, so now let's look at voltage. Okay, so how do you calculate voltage? Okay, so voltage, you calculate it by dividing work with the charge. So now work, okay, work is found by force, okay, multiplied by, okay, it's found by force multiplied by um, distance, okay, in the direction of that same force, okay. All right, so work is force multiplied by distance in the direction of the force. And then this here, the Q, represents the charge, okay. So charge is equals to, okay, charge is equals to the current multiplied by time. So this will be equals to, okay, I'm still simplifying. The force is mass multiplied by acceleration, then multiplied by the distance there, divided by current, okay, multiplied by the time. So now I can put the units. So what are the units for mass? This guy here, mass is kg. Okay, the units for the acceleration, we derived it on question 1. That's simply m s to the power minus 2 multiplied by the units for the distance. Okay, the units for the distance are going to be m. Okay, and then I'm dividing this by the units for the current. So current is measured in amperes, then multiplied by the units for the time, which is a second. Okay, so you see that on top there, I have m and m, so I can add them. So I have kg m squared, and then s to the power minus 2, and then over a s. Okay, so I can actually bring the a and s on top. So this is the same as kg m squared s to the power minus 2, and then these ones were down, right? So they can come on top and then they will have a negative power. So it will be a to the power minus 1 and then s to the power minus 1. So I have s which I can combine. So that will just be kg m squared. This s and this s will combine. So minus 2 plus minus 1, that will be s to the power minus 3 and then a to the power minus 1. Okay, so these ones here are the base units for the what? For the voltage. So I'm just now going to replace there. So I'll say resistance, which simply means ohms. Okay, the units for the resistance is ohms, is equals to. The units for the V are these ones that we have just found there. Okay, divided by the units for the current, which is amperes. So I'll just write A there. Okay, so now A, you can see that A here is in the denominator. So I can take it up. So it will be kg m squared s to the power minus 3 a to the power minus 1. This one here, it was in the denominator. When it comes up, it comes with a minus 1. So it means the units, okay, or the base units for the ohms or for the resistance are simply kg m squared s to the power minus 3 a to the power minus 2. Okay, so these ones here are actually the what? The base units. All right, so let's look at the last one, which is energy. Oh, no, this is not the last one anyway. We still have question 4. So energy, I actually derived it when I was saying gravitational potential energy. So here they just said energy. So you can use any formula, okay? If you want, you can use this one. So energy is the same as, okay, work, which is the same as force multiplied by distance. The force is the same as ma multiplied by the distance, and this m here is the same as kg, its units. Acceleration is m s to the power minus 1. D, okay, is m. So this will just be kg. I combine these m's, so it will be m squared s to the power minus 1. Okay, so those are the units for energy, and I said you can find them using anything that you can think of. Okay, we also did with potential energy, we still found the same. Okay, still found the same there when we are on, was that, what was that? Oh, this one here should be to the power 2. Okay, sorry for that. This is power 2 because this is the acceleration. Okay, all right, so that's how we can derive for energy. And then now we look at the last question in this video. Okay, so we've been given this question here. They're saying, what are they saying here? Okay. Okay, so they're saying find the SI units of mu. You can see mu there in the expression below. So this is the expression here. So if you can't see, this is Q is equals to pi. Okay, and then there's like a symbol like a P, which represents density, and then G H D to the power 4 divided by 130 L and then mu. Okay, so this is the expression that we've been given. And then they're saying we should find the units for mu. So we're finding the units for this guy here. Okay. All right. So where P is the density. Okay. So this guy here is the density. G is the acceleration due to gravity. L is length. And D is diameter. Okay. So here they also forgot to mention the units for this H. Okay. So H will also be in meters. So this formula actually, okay, this formula here is for it's the formula, okay, for what we call as okay, it's a formula for what we call as the Huygens, okay, Peisuli equation. Okay, so the Huygens Peisuli equation is given by that. So maybe I should orient you on what all these things mean. So this Q here, okay, in this equation represents what we call as the volume flow rate. Okay, it represents what we call as the volume flow rate. So Q represents the volume flow rate. So the volume flow rate is simply meaning that at what rate is the volume flowing. So simply meaning that Q, okay, it's V over S. So the volume is meters to the power 3, and then time, okay, I should have written T here. Okay, T. And then the units for time is second. So meaning the units for this Q, which is just the volume flow rate, or the volume, the rate at which the volume is flowing, okay, will just be M to the power 3, S to the power 1. Okay, so that's the volume flow rate there. And then pi, this one here, pi is a constant because pi is equals to 27 over, I mean 22 over 7, right? The 130 is the constant, okay? So they won't really matter when we are finding the dimensions there. So now P, we've been told, is the density, right? Okay, so we know the density is kg, okay, per meter cubic, or we can write it as kg meter to the power minus 3. Okay, that's the units for density, okay, when we are expressing them in terms of the kilograms and the meter. All right, and then H, I said that's just height, okay? So that will be represented in meters. The D, they've told us is diameter. So diameter, again, that's just the length. That will be represented in meters. Okay, and then the L, okay? The L, we've been told it's a length. So length, height, uh, distance, okay, they are all represented in meters. All right, and then this one here, the mu, represents what we call as viscosity. Okay, so we have to find the units for this viscosity using the units of all these other things that we know. Okay, so the first thing will be to arrange this equation in such a way that the mu is the subject of the formula. Now, when you're finding units or base units in dimensional analysis, you always ignore the constants. So this pi here is a constant, so I ignore it. This 130 is a constant, so I ignore it. So I'll just have Q is equals to P G H D to the power 4 divided by L and then mu. Okay, and then from here I'll say cross multiply. So it will be Q L mu is equals to P G H D to the power 4. So meaning that mu will just be equals to PG H D to the power 4 divided by L cubed. So this will be equals to Okay, so its units now for this mu, I'll just be replacing now. So P is the density, which is kg, okay, meter to the power minus 3, multiplied by acceleration, acceleration due to gravity. Oh, I didn't put it here. So the acceleration, we know it's a meters and then s to the power minus 2 like this. Okay, I did put it there. So the units for this is just m s to the power minus 2 multiplied by the units for the h is meters. Then the units for the d, which is diameter, it's just length, it's also meters. But this here is to the power 4. So I write m to the power 4. Then I'll divide all this by the units of L, which was just length, so m, okay? And then Q, the units are m to the power 3, s to the power 1. So this will just be equals to, okay? So let's just combine whatever we can combine. So on top, I have kg. This is the meter, 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 meter. So I can combine their powers. So this one is power 1, this one is power 1, this one is power 4. So minus 3, okay, plus 1, plus 1, plus 4. Or we can say 4 plus 1, that is 6, and then 6 plus minus 3. So that I'll get m to the power positive 3, okay? And then the s still remains s to the power minus 2, okay? And then I'm dividing this by m. Now this m is to the power 1, this one is to the power 3. So that is m to the power 4. And then I have s to the power 1. Okay, and then from there, what do? Okay, I take whatever is in the denominator to the numerator. So that one will be mu, it's equals to kg m to the power 3 s square to the power minus 2 multiplied by this guy goes on top, so it becomes m to the power minus 4 multiplied by this guy goes on top, becomes s to the power positive 1, because here it's negative, so when it goes on top it will be positive 1. So this will just be, I combine the m's and the s's. So m power 3 power 4, that will just be m to the power minus 1. Okay, just be m to the power minus 1. And then s to the power minus 2, s to the power 1, that will just be s to the power minus 1. Okay, so these here are the derived units for mu, which represents the viscosity. Okay, which represents the viscosity. All right, so that's all for this video. Okay, I hope you learned something. If you have any questions that you need, okay, you can easily inbox me on 0779 96 40 10. Okay, and I'll be available to assist. So in the next videos, okay, we'll be looking at other questions in this tutorial sheet. Look at question 5, 6, 7, 8, 9, 10, all the way up to what? 15. All right, so see you in the next video.